Welcome to question 2 of the 2016 Mathematical Methods Exam 1 for the Southern Hemisphere. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So for question 2 we have the function f with a domain of negative infinity to a half, where f of x is the square root of 1 subtract 2x. For part A we're asked to find the derivative f dashed of x. So while this looks like a simple enough function, we actually need the chain rule to differentiate this. And that's because there's an inner function and an outer function. So for this, we're going to let the inner function u equal 1 subtract 2x. So therefore our y is equal to the square root of u, which is the same as u to the power of a half. And then we need to calculate du dx, the derivative of 1 subtract 2x, which is minus 2. And we also need to calculate dy du, which is equal to power out the front is a half, u to the power of, and 1 off the power gives negative a half. And that can actually be written as 1 divided by 2 square root of u. So from the formula sheet we know that the chain rule, which calculates dy dx, is equal to dy du multiplied by du dx. So therefore f dashed of x, the derivative we are asked to find, is equal to dy du, so that is 1 over 2 times the square root of u, so 1 divided by 2 times the square root of u, but again u was 1 take 2x, and we multiply that by du dx, which is minus 2. So we can simplify that down, so 2 and 2 can cancel, but there's still going to be a negative here, so don't forget that. And the answer is going to be negative 1 divided by the square root of 1 subtract 2x. So that is the answer to part A of this question. So from the examiner's report we can see that this question was quite well done, with most students utilising the chain rule on the expression that involved a fractional exponent, which is the u to the power of a half we saw on the previous page. However, many students missed the negative sign in their final answer, forgetting that the derivative of 1 subtract 2x, which is our inner function, was actually negative 2. For part B of this question, we're asked to find the angle theta from the positive direction of the x-axis to the tangent to the graph of f when x is equal to negative 1. And the angle is to be measured in the anti-clockwise direction. So for this question, we need to remember that tan theta is actually equal to the gradient. So the tan of an angle is equal to the gradient of a straight line. And not that you need to do this, but it is helpful to maybe have a very quick sketch of what's actually going on for this function. So the function f of x is a square root graph, and the 1 subtract 2x actually gives an endpoint at a half, and that's actually given up here in the domain. And the negative reflects it over the y-axis or the f-axis. So this actually looks like this function here. And then if we draw on a tangent to the graph of f at the point x equals negative 1, so that's around here, our tangent would look something like this. And we can see that from the positive x-axis there's some angle here that's created, and that's what we're actually being asked to find in this question. So the other thing that we need to know is that the gradient of that tangent line is related to the derivative we just calculated. So that means that tan of theta is actually equal to the derivative f dashed evaluated at negative 1. So therefore tan of theta is equal to, so if we think back to the derivative function that we just calculated in part A, we had negative 1 divided by the square root of 1 subtract 2x, but here we're putting x in as negative 1, so this will give us negative 1 divided by the square root of 3. And now this is an exact value that we need to remember for tan, and based on our diagram we can see that it is between 90 degrees and 180 degrees, so it's an obtuse angle. And we know that that angle in radians would be 5 pi on 6, so that's in radians, or alternatively the angle is equal to 150 degrees. So either of those answers would be accepted here, and that is the angle that is created by the tangent line at x equals negative 1 and the positive direction of the x-axis. So we can see that this question was not well answered. So only 20% of students got full marks and 42% of students got no marks for this question. Many students who knew the connection between tan theta and f dashed of -1 had difficulty finding the required angle, and that was largely due to students not knowing the exact values of circular functions in all quadrants. So it's a really timely reminder that you need to know those exact values for your exam 1. Many students incorrectly assumed that the gradient was equal to f of -1 rather than f dashed of -1, or wasted time finding the equation of the tangent line rather than just working with the gradient of the tangent line, which was much more efficient in this case.